Hello again, everyone. This is section 13.7, writing equations given the graph. Before you do anything, you should print out this worksheet. It's called Skills Practice 106, super exciting name. It's on Classroom, and you should also get yourself some colored pens, pencils, highlighters, whatever. If we were doing this in class, that's exactly what I would be telling you to do. Okay, so you have these graphs, and the thing that you need to remember most is that all graphs can be written as a positive sine curve, a reflected sine curve, a positive cosine curve, a reflected cosine curve. Every single graph has those four options. Which ones do you need to know? You need to know all of them. So when you're doing the homework, I would recommend you practice doing a mixture of the four. So the first thing I do for all of these graphs is I draw in the sinusoidal axis. And the sinusoidal axis for this particular function, number 1, is at -2. This means that this graph has been shifted down 2. The amplitude, let's go back. It doesn't matter if I use cosine, reflected sine, positive sine, reflected cosine, it doesn't matter. All of those have been shifted down 2. The amplitude for all four of those going to be from the sinusoidal to the high point or the sinusoidal to the low point. So the sinusoidal, hopefully you can see this. The sinusoidal from the axis to the high point is a distance of 4. So that's my amplitude. That's my amplitude. Okay, the period. Again, I'm a broken record. It doesn't matter which curve you choose. The wave from beginning to end is the period, and it is the same for all functions. So this is where your colored pencils might help. Let's say I choose reflected sine. I should have used a highlighter. That is a reflected sine curve. It starts on the axis, it goes down, comes up, and then it goes back down. The period of this particular sine curve starts at 0, ends at 12. So the period, if I choose this function, is 12. But guess what? Let's say you want to use a positive cosine curve. Okay, if I want to use a positive cosine curve, so use a different color or a highlighter. So from the high point down, back up to the high point, that's also a distance of 12. This increment, see how you're going by 3s? So if you go left, it's -3. So from -3 to 9 is also a distance of 12. If I do a reflected cosine curve, I'm going to run out of pretty colors here. If you use a reflected cosine curve, that starts at 3, goes up, down, ends at 15, again, a length of 12. So I'm going to choose the curve last. I'm going to use all the other information first because, again, amplitude, period, and vertical shift, doesn't matter which function you use. So let's pretend we're going to use a reflected sine curve. And the reason why I say that is because the reflected sine curve starts on the y-axis, no shift. The reflected sine curve starts on the y-axis, no shift. So the period is 12. That's not B. That is not B. So I'm going to do degrees. And the reason why I'm going to do degrees is because there's no pi's involved. So I'm going to assume we're in degrees. So 360 over B is equal to 12. 360 over B is equal to 12. Therefore, B is, oh my goodness gracious, how about 30? What you don't know is that I've got my calculator off to the side and I'm cheating. But it's not really cheating if I'm telling you that I'm doing it, is it? I guess it's still kind of sort of cheating. All right, here we go. Y equals down 2, that's -2. I'm using a reflected sine curve, so it's minus. The amplitude is 4 times the sine of B, which we just determined was 30 degrees theta. Let's do this as a positive cosine curve. Let's do the same problem as a positive cosine curve. Okay, positive cosine curve. Y equals -2 plus 4 cosine, down 2, amplitude is 4, B is 30, theta. I can start here at -3, or I can start at 9, or I can start at 21. There's a lot of correct answers. So I'm going to go with the shift left 3, which would be plus 3. Sorry, you know what? I'm going to write that for you down here. -2 plus 4 cosine 30 theta plus 3. Hopefully you can see that. You could also, if you wanted to, you could have said, okay, positive cosine curve is starting at 9. So you could have said -2 plus 4 cosine 30 theta minus 12. Sorry, no, not 12, 9. 9. Just kidding. Okay. Let's look, I'm not going to do all of these, okay? I think it's just too much. So how about numero, let's do, if you're probably sitting at your desk, Miss Babiak, do number blah. Let's look at number 6. 6 is kind of funky. It's got all these waves. Okay, so again, find the amplitude, find the vertical shift, which is the sinusoidal axis. I just like saying that, sinusoidal axis. And let's also figure out B. So period, which is going to help us determine B, vertical shift, which comes from the sinusoidal, and amplitude, which also comes from the sinusoidal. So what's nice here is that they actually drew in the sinusoidal for you. That's fantastic. This is down, sorry, it says down 3. So it's going to be y equals -3. Plus cosine, minus cosine, don't know. Amplitude is 5. So I'm going to leave some, well, I'm not going to leave space. It is, so it's going to be 5 cosine, 5 sine, maybe it's negative, maybe it's positive. And the period. Okay, so this is a little funky. It looks to me like I'm going from -1 to 1. Looks like I'm going from -1 to 1, which is a distance of 2. Hope you agree with that. From -1 to 1 is 2. So the period of this function is 2. So therefore, 360 over B is 2. So B is going to be 180. I really hope you can see all of this. All right. We know our amplitude is 5. We know our sinusoidal is -3. And we know our period is 2. So the next question is, you have 4 options. Sine, reflected sine, cosine, reflected cosine. How do you know which one to choose? And I will tell you which one to choose. Always look at the function that starts on the axis. Then there's no shift. If you're on the axis, there's no right, there's no left. It's just boom, right here. So which function, if I'm starting at the minimum point, and I go up, and I come down, which function looks like that? From minimum up, last time I checked, that is a reflected cosine curve. Don't say it's negative. Negative isn't a really great term. It's a reflection. Okay, so if it's a reflection, it's going to be minus the amplitude is 5 times the cosine of B, oh, it's up here, sorry. B, which is 180 theta. Okay, let's go for, let's do a positive sine curve. And the reason why I made that noise is because this requires that you do some approximating. So the question I'm going to get is, well, Ms. Babiak, on a quiz or a test, are you going to make us approximate like that? And the snotty answer is, well, there's not going to be a quiz or a test. But you should still recognize that halfway between the low point and the high point, halfway between the low point and the high point is the midpoint. So take a look at that. Halfway between the minimum to the maximum is the midpoint, and the midpoint between 0 and 1 is 1/2. The graph is really small, and I'm going to have a hard time writing that in. So I'm just going to put here that the positive sign starts at an x value of 1/2. So this is, I know I keep saying this point, this point, this point. There's so much color drawn on that. I apologize if you're having a hard time seeing it. We're at 1/2. Okay, so I'm going to do a positive sine curve. That's going to be -3 plus 5 sine plus positive, starts on the axis, goes up, down, back to the axis. And this is going to be 180. B doesn't change. B doesn't change. And that's going to be theta minus 1/2. This means a shift right. That means a shift right.